Hi everyone, this is Mrs. Hutchinson, and welcome back to chemistry. Today we're going to continue our discussions with scientific measurements, but now we're going to really talk about how to properly count significant figures, and really what significant figures are. But before we do that, we're going to talk about precision again. So remember in our last video, accuracy meant that how close the measured values are to the accepted value, and precision is how close the values are to one another. But the question really states, well, how precise is precise? What that means is, how close do the numbers have to actually be in order to be considered precise? So the number of decimal places that are shown in that value that we're looking at gives us an idea of how precise they have to be. In other words, for this particular example, if our measurement is 18.0 grams, what that's telling us is that, well, the instrument that we're using must be precise to the tenths place. Otherwise, we would have simply written 18 grams. Just easier. So, what we can do is we can figure out how precise each piece of equipment is, and then that'll tell us how precise our measurements need to be. To take measurements, we actually have to use two tools. First would be the measuring tool itself. So our graduated cylinder, or our Erlenmeyer flask, or our beaker, or our ruler. And then the second tool is your eyes. So here's how to measure properly or precisely. You're going to measure out to the last marking or gradation on the tool. Gradation is just a big term for marking. And then lastly, you're going to take the measurement out to the last or final digit using your eyes. So here's what I mean by this. Let's just say that we have a graduated cylinder here. And we're reading 9 milliliters and 10 milliliters. So the smallest gradation here, the smallest markings, would be to the 1 milliliter mark. And let's just say that we have a liquid, a nice red liquid. Well, let's just say that we have our meniscus comes down to right here. So our eyes would read this to be around 9.5 milliliters. So we measured out to the smallest gradation, the last gradation, which would be the 9. And then our eyes took it out to a further digit. We said, yep, that's around 9.5. That's how to properly take measurements. And I'm sure you've been doing this for a while. So what we're going to do is we're going to repeat this measurement several times to ensure that our instrument that we're using is precise. Now, if all the repeated measurements you get do not vary by more than 1 in the smallest gradation that your instrument is capable of, then your instrument is precise. Meaning, if we had taken that measurement on the graduated cylinder several times, and it didn't vary by more than 1 in the milliliters place, in the ones place, then our graduated cylinder is precise. However, if we were to repeat that measurement several times, and we do get variables that happen to differ by more than 1 in the smallest gradation, then our instrument is not precise, and we either have to fix it or not use it. So here's our example, because this can get a little confusing. The smallest divisions on a graduated cylinder are in fact 1 milliliter. A student measures the volume of a certain liquid 3 times and records her data as 5.6, 5.4, and 6.0. Is the graduated cylinder precise? The answer to this question we will get to in just a minute. But what you want to look at are the smallest divisions. So the numbers here that we're focusing on are in the ones place. Does that vary? So 5, 5, and 6. Does that vary by more than 1 milliliter? And the answer to that is no. So, is this graduated cylinder precise? You betcha. It absolutely is. Okay. So now what we're going to do is really determine our measuring tool's capability. So I put up here thermometers, I put up graduated cylinders, and rulers. So we're going to work our way from right to left, actually. So on the right here, we've got our thermometer. Thermometers are always measured in degrees Celsius in chemistry. So let's take a look and see the tool's measuring capability, meaning how far can the tool itself actually measure out to be. So we notice that the alcohol in the thermometer is 25 maybe. So it can measure to the 1 degree. Our eye will read out to 1 decimal place past that. So 0.1 degrees Celsius. So we're going to measure this several times and we're going to say, yeah, it's definitely precise because, well, it comes out to around 25 every time. 0.0 degrees Celsius. Taking a look at our graduated cylinders. This graduated cylinder, it is going to read out to the 6 point, you got it? Yep, 10th place, well done. So, because you guys are genius and I know you're thinking of it, so this measures out to the 0.1 milliliters. So our eye will read out to the 0.01 milliliters. And yes, this tool is precise. And if we take a look, it's going to be 6.123, say 6.31 milliliters. And then here, let's just measure this little brick. I don't know. My drawing skills aren't good. Don't mind this piece over here. Don't mind that piece. Not good at drawing. So let's measure this out. Our rulers will measure out to the 10th place of a centimeter, also known as a millimeter. If you want to write that, that's fine. Our eye will read out to the 0.01 of a centimeter. And so if we look at that, that's maybe around 5.00. So yes, it is precise, and it's 5.00 centimeters. So every time you take measurements, you want to take them out to the appropriate decimal place. So now, we're going to talk about what values are known as significant. So any value that gives us information, useful information, is said to be significant. And significant figures are all the numbers in a tool that were actually measured by the tool's scale and capability, plus one uncertain measurement. This is the definition of a significant figure. So that uncertain measurement is the measurement that you took with your eye. So when you were looking at the measurements on the previous page, what you saw might have differed from what I saw. So that's the uncertain digit that we're talking about. So you always have to have one digit that you read with your eyes, a little farther than what the actual tool is capable of. So here's how you measure significant digits or significant figures. Now there are several different ways you can learn this, and I'll have other videos for other methods to learn this, but I've found that this one, although it doesn't necessarily go in depth about why we learn, not why, I should say, but why it doesn't go in depth about really how we determine which variables to count, this is sort of an easier way to understand it, which is why I like it. First, you need to know geography. So you need to be aware that the Pacific Ocean is on the left of the U.S. and the Atlantic Ocean is on the right. So now we use alliterations. So if the decimal is present, then we start at the Pacific side of the number. And then we'll start the arrow at the first non-zero digit and end the arrow at the last digit of the number, and then count all of the digits under those numbers. Doesn't sound too bad. Promise you it's not. Here's what I mean. The first step that you have to do, or the first thing you need to do, is take a look and see, hey, do we have a decimal even in our numbers here? Yeah, I mean, looks like in all of them that we do. So, since our decimal is present, we're going to start from the left side. So we're going to start looking, if I can draw our eyes. Woo! Going to start looking at the number. It's a creepy eye, but whatever. Looking at that number from the left side. And we're going to place our dot over the first non-zero digit. Now, what a non-zero digit is our digits 1 through 9. Okay. So we place our dot over the first non-zero digit, and then we continue our arrow in the direction that we were originally looking, so from left to right. And then we count all of the digits underneath that arrow. So we've got 1, 2, 3, 4, 5. So this number is said to have 5 significant figures. If we were looking at the next one, first thing you want to look at is, do we have our decimal? We sure do. So that means that we have to take a look from the left side. So here's our little creepy eye looking at it from this direction. We're going to place our dot over the first non-zero digit and continue our arrow from left to right. Count all of our digits underneath the arrow. And so we wind up with 4 significant figures. Here's the next one. It's a little trickier, but we notice, all right, there's a decimal there. It's still present, so we're coming from the Pacific side. So here's our little creepy eye. You'll get used to it, I promise. As we're looking and scanning, we want to place our dot over the first non-zero digit. So we notice we didn't put our dot over these 2 zeros because they're not significant. So you want to place your dot over the first non-zero digit and then continue the arrow in the direction that we're looking. Count all the dots. Count all the numbers underneath that arrow, and you'll get 4 significant figures. We'll do the same here. We're going to continue to look from our creepy eye because we have a decimal that is present. So we're going to look from the Pacific side and continue to move left to right. Place our dot over the first non-zero digit, and we have 3 significant figures. If you understand this, you can move on. You can continue and do these next ones on your own. I'm going to continue to talk through them. So we've got our decimal, it's present, so we're looking from the left side. We're going to place our dot over the first non-zero digit, and we're going to count all of our digits underneath, and we have 6 significant figures. Next one, our decimal is present, so we place our dot over the first non-zero digit, count all of the numbers underneath that arrow, and we should have 5 significant figures here. Taking a look at the next one, we've got our decimal, so we place our dot over the first non-zero digit. We've got 4 significant figures. And then next one for H, whoopsies, that was silly. For H, we've got our decimal that is present. We place our dot over the first non-zero digit, draw a teeny tiny little arrow, and we've got 1 significant figure. So one thing that I do want to show you would be what happens if we have scientific notation. So let's just say this was our scientific notation. The numbers that are written out here prior to the 10 and the exponent, those are all considered significant. So they're all considered to be sig figs, which means when we have scientific notation, any number that is written out those count. So for this number here, for this scientific notation, 1.23 times 10 to the third, we've got 3 significant figures. You might want to add that to your notes. Okay. Next, we've got our second alliteration here. If our decimal is absent, we come from the Atlantic side. So absent, Atlantic. So present Pacific, P and P, absent Atlantic. Same idea, except now we're looking at the number from the Atlantic side. So we want to take a look at our numbers. We want to see, do we have a decimal? We do not. Our decimal is absent, so we're going to look at our numbers from the creepy eye on the Atlantic side, looking at it from this side. So we're going to place our dot over the first non-zero digit, and then continue the arrow in the direction with which we started looking. So we have 4 significant figures. Take a look at B. We have no decimal, it is absent, so we're going to take a look from the Atlantic side, creepy eye, and we're going to place our dot over the first non-zero digit that we encounter, make our baby arrow, and we've got 1 significant figure. Next one, we've got our creepy eye coming from the Atlantic side, because the decimal is absent, so we're going to place our dot over the first non-zero digit, continue our arrow, and we should have 3 significant figures. And then the next one, we've got our creepy eye looking at it from the Atlantic side, because our number does not have a decimal, so it is absent. We're going to place our dot over the first non-zero digit that we see, looking from right to left. Count all of the digits underneath, and we should have 3 significant figures. If you're good at this, go ahead and move on to the next ones. As you can see, I kind of just decided randomly how to do my alphabet, so just have fun with that one. So taking a look at the next ones, decimal is absent. We place the dot over the first non-zero digit, draw our arrow. We should have 3 significant figures. Next one, absent. Put our dot over the first non-zero digit. We should have 1 significant figure. Next one, decimal is absent. Place our dot over our first non-zero digit. 1 significant figure. And then last but not least, our decimal is absent, so we start from the Atlantic side. So we're going to place our dot over the 3, and we are going to draw our arrow from right to left, count all of what's underneath, and we've got 5 significant figures. So yay! That's how you count significant figures. Hoorah! Go team! Now, also, if we have counting numbers, meaning if we have, say, 12 students in the room, or 25 students in the room, or 1 dog right next to me pouting because he got in trouble, okay? Those are counted numbers. They're said to have an infinite number of significant figures. So, 16 students in a room is said to have an infinite number of significant figures because there's no uncertainty. You either have 16 or you don't. It's not like you cut somebody in half. So we either have 40 cents in pennies or we don't. Well, the rabbits thing might throw you kind of for a loop because they certainly multiply like crazy. But for right now, for the immediate time being, we have 100 rabbits. So we say that we are dealing with an infinite number. This is not the best, but I really tried, of significant figures. I certainly did try to draw on that one. You'll also notice that my drawing capability is pretty pathetic. So now we're going to work on our worksheet called Counting Significant Figures. I kind of mixed up what we're doing, so you want to think about and look at, does the number have a decimal? Does the number not have a decimal? If it's got a decimal, then you want to count those numbers from the Pacific side, so the decimal is present, you come from the Pacific side. Atlantic means that it's absent. So present means Pacific. Absent means Atlantic. So let's take a look at these first ones. They all have their decimal present, so we're going to be looking at it from the Pacific side on all of them. Creepy eye time. You don't have to draw the creepy eye, let's be honest. I'm just doing it so I can show you which side we're looking at. So, decimals present, we're looking at it from left to right. Place our dot over the first non-zero digit and we count, and we should have 2 significant figures. Next one, decimals present, so we're taking a look from left to right, and we have 5 significant figures. And then last but not least, decimals present, place our dot over the first non-zero digit we see, and we should have 3 significant figures. So go ahead and do the rest of these. Use your notes if you need to. And good luck. I will see you in our next video.